Looking at this problem, we have let R be the radius of convergence for the power series of the summation from n equals 0 to infinity of x plus 3 to the n power. Find R. So one of the things that you may notice here is that a sub n is just 1, so we just have that x minus c portion here, but we can still do this. So one of the things that may be important to us is our center. So just looking at this, I know that my center is going to equal -3 because x plus 3. So what we need to do is the ratio test. So some things that we want to remind ourselves about the ratio test. The ratio test is the limit as n approaches infinity of the absolute value of our terms a sub n plus 1 divided by a sub n. So we want to take the next term and divide it by the current term. Things that we know is that if it is less than 1, we converge. If it is greater than 1, we diverge. And if it equals 1, we have to try something else, or we cry. We're going to be using this knowledge to help us out when looking for our radius. So a lot of times we're going to be doing the ratio test and then assuming that we are going to be converging, and that's what's going to give us this center, this radius. So I have the limit as n approaches infinity of, I need this division, so I need the current thing that I have, so I have x plus 3 to the n power, and then I'm going to have the n plus 1 on top, so I have x plus 3 to the n plus 1 on top. So now what I'm going to do is I'm going to go ahead and kind of separate this just a little bit. This isn't necessarily something you would have to show, but this is just the why it works out. So x plus 3 to the n plus 1 is the same thing as x plus 3 to the n times x plus 3. I have the same thing on top and bottom, so I can go ahead and cancel those out. So I have the limit as n approaches infinity of the absolute value of x plus 3. So now what we're going to do is we are going to find our limit. Well, we have no more n's, so what I know is that this limit is equal to the absolute value of x plus 3, which really didn't change a lot, but that's okay. So the big thing is that we want to assume the ratio test converges. So we want to assume the ratio test converges, and that happens when whatever we get is less than 1. So we want 1 to be bigger than this x plus 3. So I have the absolute value of x plus 3. We don't have anything to multiply or to get this absolute value by itself. And we always want it in this format. X minus c, absolute valued is less than r. So we always want this format. So x minus c, absolute valued, is less than capital R. Well, this format is exactly the same. X plus 3 could be written as the absolute value of x minus -3 is less than 1. Because those are written in the same format, what I know is that r is going to be equal to 1. So our radius of convergence is 1. It's not asking us for anything to do with our interval or anything like that, so we're done at this point. We just needed to find that value.